Hello again, my dear students. I am Mr. Nasser Jabber, expert of mathematics, especially for you first secondary students. Today, inshallah, we are going to study a new lesson, which is a geometrical lesson. So be with me, please. I'll show you the first figure here. Yes, we have two polygons. This is a quad and this is another quad. This quad called A, B, C, D. And this quad called A dash, B dash, C dash, D dash. They are similar. Why they are similar? Because each two corresponding angles are equal in measure or congruent. Measure angle A equals measure angle A dash. Measure angle B equals measure angle B dash. Measure angle D equals measure angle D dash. Measure angle C equals measure angle C dash. So each two corresponding angles are congruent. There is another condition which is very important to verify. Each two corresponding sides are proportional. Each two corresponding sides are proportional means that if we have the names again, the quad A, B, C, D is similar to, the sign means similar to. A, B, C, D is similar to quad A dash, B dash, C dash, D dash. Yes, we are here so that the first two signs AB, we will say that AB over A dash, B dash, this is one ratio, equals BC over B dash, C dash, and CD over C dash, D dash. The last one is like umbrella, like that. A D over A dash D dash. Okay, if this ratio equal 1 over 2 will be equal this ratio 1 over 2 only, this ratio will be 1 over 2, and so on. When these ratios are equal sorry, that means that the two quads A, B, C, D and A dash, B dash, C dash are similar. But the two conditions must be satisfied or verified together. Let's see some presentation here. Yes, we have here similar figures. The goals means the aims. After this lesson, you have to identify similar polygons, find missing values, identify scale factor, and determine its type. Look at here. We have a diagram here. Yes, the diagram is A, B, C, D. Another diagram or another polygon, E, F, G, H. The definition of the similar polygons is they are equal in measure if their angles, the corresponding angles equal in measure or congruent, and the corresponding sides are proportional. Statements: the angle A is congruent to angle E, the angle B is congruent to the angle F, the angle C is congruent to the angle G, the angle D is congruent to the angle H. Okay, then we have to find the proportional ratios. AB here is corresponding to EF. So when we divide 6 by 12, the answer will be half. It's a ratio. And we have BC here is corresponding to the side FG in the other one. So when we divide BC over FG will be half, and so on. So all these ratios are equal and each of them equals half. So each two corresponding sides here are proportional. So when we talk about similarity of two polygons, we must verify the two conditions together. The first is each two corresponding angles are congruent. The second is each two corresponding sides are proportional. Okay, let's see the second slide. Yes, we have here two polygons. The smallest polygon called BCDA and the second one HIJG. They are similar. You know the meaning of similarity, that something is similar to something. They different in size, or even they are congruent, they are similar if verify the two conditions. Let's see similar figures here have the same what? Have the same shape, but not necessarily the same size. These two polygons or two quads are different in size, but they are similar. Okay? After that, the two polygons are similar polygons if corresponding angles, as we said, are congruent and if the length of the corresponding sides are proportional. Proportional means each ratio equals the other. When three or more ratios are equal, you can write on an extension proportional, an extended proportional. Let's see the second one. Are polygons for which all corresponding angles are congruent and all corresponding sides are proportional. You can see this. We have two rectangles. Two rectangles, we know that the rectangle, each angle is right angle, 90 degrees. So all corresponding angles are congruent or equal in measure. And the sides, this is side is 4, this is 2. If we divide 4 by 2, it's 2. And this side is 8 over 4. If we divide them, the length over length will be 2 also. So they are proportional. Polygons are said to be similar if there exists a one-to-one correspondence between their sides and angles. That means that the two polygons have the same number of sides and they have also the same number of angles and they have the same number of vertices. B, the corresponding angles are congruent and their corresponding sides are proportional in length. Okay, let's move here to the these two figures. We have two quads. The polygon SI, similar if and only if their corresponding angles are congruent and the measure of their corresponding sides are congruent too. We have here the quad ABCD, ABCD, and the other quad GHIJ, GHIJ. We can see clearly here that AB, which is 4, over GH, which is 12, if we divide them, will be 1/3. And also BC over HI equal 1/3 also. CD over IJ equal 1/3. So they are similar because the corresponding angles are congruent. Measure angle B here equal measure angle H, and you have seen the sign. Measure angle I equal measure angle C. Measure angle J equal measure angle D. Measure angle theta here equal measure angle A. So each two angles are congruent and each two sides are proportional. Proportional means that they have the same ratio. And this ratio, we called it scale factor or similarity ratio. We called here this ratio, which is 1/3 scale factor. Okay, let's go the second one. In this figure, we can see that A, B, C, D, E is a quad or pentagon. Pentagon, that means have 5 sides. And the second one, G, H, I, J, K, and they are similar. So all corresponding sides are proportional. Okay. GH, we can arrange them when we see their names. We have GH here over AB here equals HI over BC equals IJ over CD equals GK over DE, and the first was the last, GK over AE. Let's move to similarity tests for triangles. And before we talk about the similarity of the triangles, let's see an example, a simple one. We have here a polygon ABCD, and we have the smaller one A dash, B dash, C dash, D dash. AB is 8 centimeter and A dash, B dash equal 4 centimeter. BC 9 centimeter and B dash, C dash 4.5 centimeter. DC equals 10 centimeter and C dash, D dash is 5 centimeter. AD equals 7 centimeter and A dash, D dash is 3.5 centimeter. As we see that measure angle A, we can use another one. Measure angle A equals measure angle A dash. Measure angle B equals measure angle B dash. Measure angle C equal measure angle C dash. Measure angle D equal measure angle D dash. So each two corresponding angles here are congruent. Okay, let's test the corresponding of the two sides. Each two corresponding sides, we have the name of the first quad A, B, C, D, and second quad A dash, B dash, C dash, D dash. Okay, let's try to find out the corresponding AB over A dash, B dash, AB over A dash, B dash equals what? AB equals 8 here, divided by A dash, B dash is equal 4, so the answer equal 2. And BC over B dash, C dash, BC over B dash, C dash equals 9 divided by 4.5 will be 2. and we will find out that CD over C dash D dash, CD over C dash D dash equal to the last one, AD, it's as umbrella here, AD over A dash D dash equals 2. So all ratios here are equal. If we have ratios and equal, then each two corresponding sides like AB and A dash B dash, BC and B dash C dash, CD and C dash D dash, AD and A dash D dash, all of them are corresponding and proportional. This ratio equals this ratio equals this ratio equals this ratio. So we can say that each two corresponding sides are proportional, because if we divide the first over its corresponding, will be the same ratio as you see. This ratio, which is 2, called scale factor. Scale factor. Okay. Let's go again to the similarity of two triangles and focus with me to understand it. Okay, we can go to the slide. We have two triangles here. We have a postulate that logic things or logically. If we have AA similarity, AA similarity means angle similarity. Look here carefully. You will find measure angle X here equals measure angle R. Look at the sign, the red here. Look carefully. The measure angle Y equal measure angle S. So we have two angles in the triangle XYZ equal to two angles or the two corresponding angles in the triangle RST. Measure angle X equal measure angle R, measure angle Y equal measure angle S. So logically, measure angle Z equal measure angle T. Why? Why if two angles in the triangle equal the two angles in the other triangle, then the third equal the third? Think about it. Let's draw two triangles here. Triangle ABC here and triangle XYZ. Look carefully. If we have this angle will be 60 degrees and this angle will be 60 also. This angle will be 70 degrees and this angle will be 70. Do you know what the measure of this angle and this one? Of course, we know that the sum of the measures of the interior angle of triangle equals 180. The sum equals 180. To find the missing angle here, we subtract 180 minus 60 plus 70. So the measure angle of BE or Y equals sorry, these angles 60 plus 70, we have 130 here degrees, so it's 50. The angle B here is 50 and the angle Y is 50 also, 50 and 50. So when two angles in triangle equal the other corresponding two angles in the other triangle, then the third angle here equals the third angle here. Okay, so the two triangles here in this slide will be similar because it's enough to say that two angles equal the two other angles. Yes, measure angle X here is congruent to angle R. We can say the angle X is congruent to angle R, or measure angle X equals measure angle R, and the angle Y is corresponding to the angle S, or is congruent to the angle S, or we can say measure angle Y equal measure angle S. Therefore, of course, triangle XYZ is similar to triangle RST. By what? By AA similarity. AA similarity means angle and other angle. These two corresponding angles which X and R are equal in measure, and measure angle Y equal measure angle S. Let's see this slide also. Side similarity. We call it theorem SSS. What is meaning of SSS? This is meaning side. As we can see, we have two triangles. First triangle is WXV and the other one PRQ. We have here WX equals 3 centimeter, PR equals 4, WV equals 10.5, and PQ equals 14. XV equals 12 and RQ equals 16. Let's see, when we divide each number or each length of side by its corresponding. We have here the smallest side 3, we put it here, and this one is 4, 3 over 4. Is it equal 10.5 over 14? Is it equal also 12 over 16? We will find the answer will be 75 or 7.5. This is 7.5. 3 over 4 equal 10.5 over 14 equal 12 over 16 equal 7.5. So the two triangles here are similar. What are the steps to answer this question? Put the three sides from triangle in order on the top. Put the three sides from other triangle in the bottom like that, but ascendingly. The smallest side here of the first, the smallest side here over the smallest side here equal the biggest one over the biggest one equal the biggest one over the biggest one. The ratio here will be the answer. Divide out each ratio and see if all three are, or the three are the same. If so, the triangle are similar. Okay, therefore the triangle WXV similar to the triangle PRQ by SSS, which mean side. Okay, our dear students, we are going to a short break and we'll go again to
ماشي في مصر سلم عاللي ربى وعاللي علم واللي كبر واللي عقل واللي هاوي واللي فهم. وانت ماشي في مصر سلم عاللي ربى وعاللي علم واللي كبر واللي عقل واللي هاوت واللي فهم عالتاريخ اللي بيكتب اسمها في كتابه حاضر عاللي بتربي ابنها من صغره يكبر يبقى راجل عالتاريخ اللي بيكتب اسمها في كتابه حاضر عاللي سحر مالوش آخر عالبنا والبنايين والخضار والفلاحين والإيدين الشقيانين لف بعيونك وشاور انزل امشي في الشوارع زور كنيسة ودير وجامع اللي شاف غير اللي سامع مصر سحر مالوش آخر.
Hello again, my dear students. Let's verify the similarity of two triangles. If we have two triangles here, A, B, C, and this one, X, Y, Z, and we have each two corresponding angles, or at least two corresponding angles here. This angle equal in measure this angle, and this one equal the measure of this one. So the two triangles are similar. Similar by what? Similar by AA angles, which means two angles. Let's say about the arrangement of the two triangles. If we write the two triangles, we must write them correspondingly. That means that if we start saying the triangle as that, measure angle A equal measure angle X, so we write A and we write X. Okay, triangle A, triangle X. After A, we mention C. The corresponding to C is Z, and the corresponding of B here will be Y. Okay, so when we say about similarity, triangle ACB is similar to triangle XZY, and we put the sign of similarity here. And when we find out the sides, or we find the values of some sides, if we have AC equal 6 centimeter here, and this one equal 2 centimeter, BC equals 7, or we can write 9, and this one is 3, 12, and 4. If we divide AC over XZ here, AC over XZ will be 3, and CB over ZY will be 3 also, and BA over YX will be 3. Then they are proportional. These three sides are proportional, and this 3 we call it scale factor. Scale factor. And from the ACB to XZY will be enlargement, because 3 greater than 1. Okay, let's move to the next slide here. Yes. Yes, we have here another condition to similarity of two triangles, side angle side similarity. We have here SAS. Look at these two triangles. We have measure angle X equal measure angle R, and we have XW here is proportional to RP, which is 3 over 4, and XV is proportional to RQ, because they are 3 over 4. First, make sure that you have a pair of corresponding angles congruent, like x and r. Measure angle x equal measure angle r, or we can say the angle x is congruent to the angle r. Look at this proportional 3 over 4 here equal 12 over 16 equal 7.5, 0.75, or 3 over 4. Okay, this angle x equals this angle r, and it is included angle between the two sides wx and xv, and this angle r is included between pq and rq. That's the secret, that SAS, side angle side. The angle here is included by the two sides which are proportional. So if we say, as example, measure angle x doesn't equal measure angle r, but measure angle w equal measure angle p, will not similar, because the condition is the angle must be included angle between the two sides. Okay, put the two sides from the triangle, put the two sides from the other triangle, and we will have divide out each ratio, and the ratios will be equal. Therefore triangle WXV similar to triangle PRQ by SAS, which means side angle side. Let's move to the second example. We have a triangle LKM. LK equals 18, the length equal 18 centimeter, LM 15, and KM 6. We have a second one, RQ equals 30, RS equal 25, and QS equal 10 centimeters. We have to verify if they are similar or not. Yes. Test for SSS, because we have the three sides here known and three sides here are known also. Test about SSS similarity. We have the first triangle, we have 6, 15 and 18 sides. Look carefully for this. Divide by what? The smallest side here, which is KM equals 6 centimeter, must divide it by the 10 centimeter, which is QS, and 25 and 30. Notice that we start with 6, 15, 18 from the smallest to greatest, and here we also started with the smallest to greatest, 10, 25 and 30. We try to find out the ratio. It's 0.6, 0.6, 0.6, so they are proportional. Therefore the two triangles will be similar. Yes, triangle KML is similar to triangle QSR by SSS similarity, or side similarity. Let's move the next example. We have two triangles, as you see here in the figure. AC equals 6 centimeter, AD equals AD here from A to D equals 10 centimeter. Yes, so CD equal what? Think about it. If AD equals 10 centimeter and the part AC equals 6 centimeter only, so the remainder CD equals what? Think. Yes, and we have BC here equal 9 and BE equal 15. This part BE, the whole side here, equals 15, and we have a part of it CB equals 9 centimeter. So think about the length of CE. Okay, we have 4 here for CD, because 6 plus 4 equal 10, and we have that AC plus CD equals AD. Yes, look at EC. EC equals 6 centimeter, because EB equals 15 centimeter, and the part CB equal 9. 15 minus 9 equals 6 centimeter. And pay attention carefully for these two angles. Yes, you know vertical angles and are congruent. Yes, look at the angle ACB. It's congruent to the angle ECD because they are vertically opposite angles. Next, you know that the sides from angles, check SAS. Check SAS means check which angle we have here. Measure angle ACB equal measure angle ECD, and we have the included sides, the including sides for it, EC and CD 6 and 4, CA and CB 6 and 9. Yes, 4 and 6 for the first triangle here, triangle ECD, we have 4 and 6. Yes, then we have 6 from the second triangle CA 6, and we have 9 here from the triangle CAB, CB equal 9. Yes, equals what? 4 over 6. Yes, 4 over 6 here. If we simplify it, it's 2 over 3, and 6 over 9, it's 2 over 3 also. So they are equal. So yes, the triangle DCE is similar to triangle ACB by using the theorem SAS, or side included angle side. Let's move this example also. Find the value of x, y, and the measure of the angle P if triangle TSV is similar to triangle QPR. Now the difference of this question that he gave me that the two triangles are similar already. Triangle TSV is similar to triangle QPR, and we have S here equals 86 degrees. The length of TS equal 4, SV equals X, QP equals 6, PR equal 9, and we have Y, which is unknown also. Let's see. Okay, back again. Yes, we will find x equal 6, y equal 10.5, and the angle P equal 86. It's no problem about this angle. Measure angle P here. Look at this. We have P in the middle. Measure angle P in the middle here equal measure angle S in the middle here. So measure angle S equal measure angle P equals 86. And y x equals 6 centimeter. Let's explain it here. We have the two triangles. Okay, this one Q P R, and the smallest one TSV. The length of QP equals 6 centimeter. The length of TS equals 4. This is 9, and this is X. This is 7 centimeter, and this is Y. And he told me that the triangle TSV is similar to triangle QPR. Okay, let's go to the next step. We have the two triangles. TSV is similar to triangle QPR. So TS over QP must equal SV over PR, equal the third one TV over QR. Let's go and try to substitute here. TS equal what? Where's TS? TS here equal 4 centimeter. And QP equals 6 centimeter. SV, where is SV? Equal X. Put here X. And PR is 9. TV here is equal 7. And QR is Y. We have studied from the last studying that if we have two ratios are equal, then they are proportional. That means that X can be given by, or we can reduce it by 4 multiplied by 9 divided by 6. 4 times 9 over 6. And Y equal 7 times 6 over 4. So you will find that X here equals 6 centimeter and Y here equals 10.5. You see now it's very easy for you, my dear students, to calculate this question. Okay, let's move to the second slide. We have example here. We have two trapezoids. A, B, C, D is the first one. Is similar to trapezoid P, Q, R, S. List all the pairs of congruent triangles and write the ratios of the corresponding sides in a statement of proportional. Yes, try to think and answer with me. The first, we have the angle A is congruent to the angle P. The angle B is congruent to the angle Q. The angle C is congruent to the angle R. The angle D is congruent to the angle S. And it's easy to see that AB over PQ equal BC over QR equal CD over RS, and the last one AD equals PS. Let's move to the second example. We have two triangles. The request is decide if the triangles are similar. We have three sides here. The triangle LMN 10.5, 18, 12, PQR 12, 4, and 9. Look at this. The triangles are not similar. Why? Let's explain to you. Here we are two triangles. And we have the sides of the two triangles 10.5, 18, 12. This is L, M, N triangle, and we have this triangle, we called it P, Q, R, 9 centimeter here, 4 here, and 12 here. Okay, let's use the method that we explain. We have here three sides and see fractions for them. Let's start with the triangle PQR. There is the smallest number here, 4, and after that 9, 12. 4, 9, 12. Let's move to the second triangle. We have the smallest side is 10.5, 12, and 18. Look carefully, and you can use your calculator to decide. We have here a fraction 4 over 10.5. The answer will be 8 over 12. 8 over 21, and this one 9 over 12. The answer will be 3 over 4. We needed to complete. We have found that sorry, 4 over 10.5 is equal to the ratio 8 over 21, and 9 over 12 will be 8 over 21, and here 3 over 4. Okay, this ratio doesn't equal okay, we have 4 over 10.5 here, the ratio equal 8 over 21, but 9 over 12 equals 3 over 4. So this ratio doesn't equal this ratio, so they are not proportional. So triangle LMN doesn't similar to triangle PQR. My dear students, we have seen that geometry and similarity especially is very easy and enjoyable to study. I am here with you, Abdul Jabir, and we have a wonderful team of Studio 12 in the Egyptian channel for education. Thank you very much. Until we meet again next week, so goodbye.